Good morning, computer class. Today we're going to talk about using variables and strings. Hopefully we get to strings today, but if not, we can always work on that next week. What I need you to do is log in to Repellent. So I'm going to log in here. And we're going to go to our class. And you'll notice we have quite a few assignments. They're pretty small, but we're going to first just practice a few things and go over what strings are and the different variables that we have and how to declare them. So let's go to our practice page. So my practice page, we started out with this. Again, we started out with a public class main, so we'll want to keep that. And then we have our driving function, and we printed out some things. So I'm going to go back through here, and I'm just going to edit. And if you want, you can unsubmit, I think. If you unsubmit and edit, you didn't have to submit your practice page. You'll just want to unsubmit if, in fact, you submitted it. All right, so here we go. We've got our public class main and our public static void main, and we're going to be dealing with strings. So in this first one, let's talk about our first string. So we're going to declare a variable, and we're going to declare it as a string s, and it's going to be equals, and we can put hello world. This is me. So once we declare our variable s as a string, we can go to the next line and print out that string. So we're going to do system.out.println. And instead of printing out that whole string, hello world, this is me, we're just going to call upon that variable. So we'll call upon s. I'm going to make this, I think I can make this, oh, it's already bigger. Here. So I'm going to move this over so you guys can see this a little bit more. Okay, so I'm going to run this, and it should print out. Oops, I forgot a semicolon. Always remember, again, after any line of code that we want to execute, a semicolon. So again, we have a string. It's variable s, and we're just call uponing it to print out. Perfect. So that is a simple string variable. And it's used to store things within the quote. So we're storing hello world, this is me, exclamation point within those quotation marks, and we're just calling upon that entire stored information or stored data. All right, so let's go ahead and we can do an integer. So after this, or I can delete this, and let's call upon or declare a variable as an int. Integers are stored positive, can be stored as positive or negative. So let's go ahead and we're going to keep the public class and a public static, and we're going to declare an integer variable. So int, our variable name, we could call it age, equals 25, semicolon, and let's print out that variable. So we're going to do system out print, and call upon the variable age and semicolon. And now we're going to hit run, and it prints out 25. So the nice thing about calling upon a variable is if we wanted to change the number, we don't have to change the actual variable. We can just change the number. So if we wanted 150, run, it'd do 150. All right, and then let's talk about double. Doubles are used to store floating point numbers or decimal fractions. It also could be known as double precision. So if I ask you for a double or double precision, it's the same thing. Okay, so let's talk about this. I'm going to go ahead and delete this. So to declare a double, it's just going to be the word double. I'm going to use the letter D. And I'm going to do negative 137.803.657. And then a semicolon. And I'm going to do system printout. Out at print line. And the letter, oops, and the variable D. And and there we go. Now, what happens if I did, if I change D? If I change D to be scientific notation. So if I did D equals 1.456667, and then the uppercase E 23. And I'm going to run that. Perfect. Or if I did this, if I got rid of that and just did 1.456667 times 1023. So you notice that it does do quite large numbers. For scientific notation, if we had to do that, and I think one of your practices is scientific notation, you would just use the E. So I'm going to do this again. So 1.4567 E 23, and that would give you a scientific notation. Just so you know. Okay, so those are some samples. We declared them. So as this example, let's go ahead and do double x equals 1.6. When we're doing this, we are not only declaring a variable to be a double, but we're also initializing x to be the value of 1.6. So I'm going to show you this. So we're declaring x to be a double and initializing x to be equal to 1.6. So we're doing two things here. We're declaring it and assigning it a value. So that's important to know. So let's talk about some legal and illegal things. So let's say I'm declaring, let's talk about this. Let's do an int, and I call RWS. I just created a variable called ARWS equals 47.896. And then I call upon it to print. Let's see what that does. Now it's not going to work because this is a double and not an integer. So you want to be careful how you're declaring your variables. So it's important to know those things. Also, another thing is when we declare a variable name, again, make sure it's all one word. Don't use spaces. And in your notes, in Schoology, I put on things what are legal names and what are illegal. So you don't want to use a dash. So for example, you don't want to use Stu. This would be a bad example. I'm just going to do, this would be a bad example. Because of that hyphen or minus sign. You don't want to use a semicolon in there as your variable name. I have a hard time knowing that it's going to have, oops, for example, it's going to have an unexpected semicolon between the D and the 8. So make sure it's all one word. So those are important rules. So you can practice. You can do, let's see, we can do, another one would be a string. A string me could be, hey, will this work? And then don't forget your semicolon. Perfect. Another one would be an int. Get rid of the quotation marks and you might have, and run that. Oops, I keep forgetting that semicolon. And then a double would have some type of decimal. Here we go. Perfect. So those are some simple declarations of variables.